Hello, everyone. My name is Demetrio Zourarakis, and I'm welcoming you to Kentucky State University's GIS Day 2020. It's a virtual day. I have prepared for you a couple of short presentations, videos, that if you enjoy, maybe you can share them with others. I'm going to share my screen. So the purpose of this first video is to show how LiDAR has impacted GIS and has become integrated into everyday workflows. More and more, we are surrounded by a new type of data, point clouds, that are different than the typical data models that we are accustomed to, and they contain information that's critical and that did not exist before LiDAR. We can extract information and bring it into our GIS very easily, and the software has become very, very sophisticated. So without further ado, I want to show you the outline of the presentation. First, a welcome, of course. Significance of the day, we'll see a slide, and we'll go online. What LiDAR has to do with GIS, some basic concept slides, and the 3D visualization revolution. That's 3D vis and temporal. I mean, we have the data are temporal in nature as well. How your career will find and has found already LiDAR data and information extracted from LiDAR. How LiDAR makes us connect with other professions. Our GIS career has been impacted in the last 5-6 years, perhaps 10 years. And how information differs from data, just geographic information systems, basically, rather than geographic data systems. And where to find out more about how to manipulate this data, how to create new layers and new ways of looking at the same data. And then a closing slide. So GIS Day, November the 18th, which is Wednesday. And if you go online, you will find out the map, find the map, and Kentucky has, let's see, four points, one of which is ours, Kentucky KSU GIS Day 2020. This virtual event will be for connecting high school students, teachers, and other interested learners to practitioners of GIS. Basically, there's a set of videos that allows you to witness how careers have been impacted by GIS. We hope you enjoy those. Remote sensing is part of that. LiDAR is remote sensing, and adjacent geospatial sciences like surveying, engineering, etc. So what does LiDAR have to do with GIS? Well, it is geospatial in nature and temporal, a highly accurate and precise coordinates and temporal timestamps for points, 3D cloud, 3D points. The points are natively georeferenced, and they are used. The uses of LiDAR are numerous, very numerous. We have just examples here. So surveys of topography and bathymetry, which is elevation and depth, bodies of water, infrastructure, roads, power lines, buildings, whatnot, transportation, networks, land cover, land use, that's a typical one, particularly forestry, agriculture, and urban versus rural. Engineering level data, now we're going to see some indoor mapping applications. Data fusion with optical, thermal, and other sensor data. colorized LiDAR is not done anymore the way we used to do it, which is with asynchronous data sets. They are not taken at the same time. Now they are, the LiDAR is scanned at the same time that the camera takes the images, so the colors are current. Could be RGB, red, green, and blue, and near infrared, etc. We'll see some of that. There's feature extraction using artificial intelligence. The algorithms have been around for a while. The mathematics of it and the statistics of it are well known. The thing is, we needed a way to teach the machine, right? The software, how to extract them. Change detection, topographic change detection, particularly when you have quarrying and mining going on, and logging, crops that grow different seasons, etc. You can use LiDAR to do that. And of course, applications to any earth science, hydrology, glaciology, geology, and other planetary sciences. So the sky's the limit. The space is the limit. So everything is about information, right? More than just data. A little bit of a concept here. We're talking aerial LiDAR, okay? Not from space, but there's LiDAR from space. And aerial could be a fixed wing airplane. That's a traditional method with a linear scanner. And there's a scanning line that zigzags, or there's different patterns, but this one is the one that's being exemplified here. The scanning swath, a nominal point footprint spacing between scanning lines, etc. Like I said, this is not a class or a course in LiDAR. It's just to show you how it fits within GIS. The data have multiple returns depending on the, what part of the object they return from. The pulse has returns. And of course, bare earth return and top of buildings are the most. We're going to show some of that. So we have here an example from NOAA where elevation and bathymetry are integrated. So we have not only what's above the sea level on the right hand side here of this slide. And then we have the under the water, shallow waters. Red, near infrared LiDAR is used for aerial applications, and blue-green LiDAR for bathymetry. So now we're going to go to a demo. We're going to see 2D visualization and 3D visualization of point clouds using ArcGIS Pro. I'm using ArcGIS Pro, even if that's the tool I use, but there's many others. I'm going to show you some resources at the end. So let's see. I'm running ArcGIS Pro 2.6.3. And let's see, version 2.6.3, and we're just going to open up a blank project, and we have our catalog pane and symbology pane. I want to just close the symbology pane. Catalog. One way to do this is to connect to a folder. Well, first off, we need a map. So we're going to insert a new map. It's going to be a new map, a 2D map, right? And then I'm going to just connect to a folder that I know has some LiDAR data. Then workshop data, last data sets, and oops, sorry. Let's connect to the data folder. Okay. So I have a last data set prepared. I will just drop it in the map, on the map. And this is the outline. What I want to, and the points are already showing. So what we want to do is we want to bring in some base map. Maybe we're going to bring in imagery with labels. And so this is a jumble of points, of course, and I can make them transparent. and see what that is. Okay, so these points are classified already, and so I'm going to just filter out and show you the ground points. Okay, there's two classes. These are the ground point, and there's a building here, and the building as a whole, the points don't show because and there's vegetation on the points. These are the ground points. Okay, so bare earth. So what I want to show you now is maybe show the buildings only, and those are buildings. I'm going to just increase this to 10 million points and maximum point density, so that we can see this. And you see this is very useful because LiDAR is much more accurate and precise than the imagery. So when the imagery was modified to be georeferenced and terrain corrected, etc. So I want to trust more my LiDAR data than my image data, right? So this shift, this displacement of the image, I can bring in this. I can convert this map into 3D local scene, which is I'm going to create one. So what it does, it creates a local scene with the same data. So I can visualize this in 3D now. Well, let's see how long it takes. It's doing it. My laptop does not have the best graphic processing unit in the world, but this now is a 3D image where we were, and showing the buildings, of course. Now the nature of the data is that the first return here is the rooftop, and there's nothing underneath, right? And then I can change this to if I wanted to change this to different, just the best ground points I can find, and it's gonna do it. These are model key points. Okay, these are the best ground points that exist to make a digital elevation model. So anyway, it's easy to manipulate, easy to bring the data, symbolize them by different. Like I said, there's not enough time on this video to do that, but connecting careers with LiDAR and GIS. GIS practitioners or GIS professionals, of course, will use LiDAR in their careers. Land surveying, engineering, and by land surveying I mean surveyors, engineers with using building information models and CAD, computer-aided design, forestry, agriculture applications, emergency response, homeland security, military intelligence, health sciences, etc. So I'm going to show a slide where we see LiDAR used to create a canopy structure and fuel load because of the wildfires. So that this is taken from the Forest Service, and it shows the LiDAR pre-burn and post-burn. And there's a lot of applications of this. The special type of LiDAR, the full waveform LiDAR, allows you to create a profile of the canopy and quantify the biomass in terms of with the purpose of modeling fires. A very important application is the digital elevation models and digital terrain models in agriculture, particularly when you want to do some contour lines or leveling, for example, rice fields in Arkansas, or other states that grow rice. Here we have on the left a LiDAR derived DM, and then on the right hand side we have also a terrain model coupled with a yield map in precision agriculture. So it's not just the images that come from the crop itself, but also see whether the hydrology of the field, determines influences yield. Engineering, we have an example with SLAM, simultaneous location and mapping. There's something called GeoSLAM, which is a trademark method, hardware and software. So we have here we have the Winchester Mystery House at GeoSLAM with all these thousands of rooms and stairways, stairwells, and that go nowhere. So we have this is from that publication, and then we have online. This is very, very common now. Online, people are publishing. We'll see some examples of that with ArcGIS Pro, publishing the LiDAR data sets, and this is this is an apartment, of course, and it's inside, right? I mean, it was LiDAR from the inside, so one can see the stairwell there. And it goes from the basement or the bottom of the building, and there's a stairwell right there. So anyway, this is indoor mapping with LiDAR, scanning everything, scanning all the surfaces and all the objects, if you wish, and highly accurate. And so using LiDAR, using GIS, we can extract information from aerial LiDAR. And one of the big things is structures, buildings. So the rooftops can be extracted very easily. Now there's well-known algorithms, well-behaved algorithms that can extract the buildings, complex surfaces now, and with using multi-patch technology, they can extrude the buildings and make them look like they are. For example, you have complex shapes for the buildings, and gable or different types of rooftops. So that is off the shelf. The packages contain tools that allow you to extract buildings from LiDAR points. Another thing is drones or UAVs that have LiDAR capability. You can also find these data sets on the cloud, and I'm using the micro drones data set. This is a LiDAR data set, and you can turn on, turn off the vegetation, and here you have your point cloud for the foreground. Now, where there's holes, obviously there's water or snow will obscure. There will be no returns, and that's probably what happened there. But it's a anyway. This is not only visualization, but you can also extract features from this this cloud. There's tools out there. So now we have a demo coming up. I'm going to just create a new local scene, and then I'm going to just look at my catalog pane here, and I'm going to go portal right online, and I have my ArcGIS online portal where I want to just look for Miami. Someone published the data, the point cloud for Miami. They scanned part of the town and the harbor, so I'm going to just bring it in here, and there it is. So I didn't have to download the terabytes of data or whatever that is. I have my Miami harbor here, and I can see the harbor and some of the skyscrapers, right? and the skyscrapers on the top are classified as buildings. So this here, this information has coordinates, elevation, class code, etc. One thing that I haven't mentioned is that there's classes, and this particular class is a class 6 is building, so the rooftop is classified right as points, and then on the side of the building is either unassigned or misclassified. So there's all kinds of sea crafts, and there's a tow ship there, etc. So you can explore the scene, visualize, look at the points, how they're classified. You can extract elevation from here, 134 meters above the datum, the vertical datum. Class code 6 is building, etc. Intensity, there's an intensity value as well. Meaning you can make a do this scene into different things. On the table of contents, you have that. Another one could be the San Diego. This is published as a scene layer, as a point cloud. So we just add to a new local scene, and here we have the aerial LiDAR. I'm going to just change the appearance. I'm going to just put about 10 million points, the maximum that I can find, and then increase my. Let's see if it allows me to do that, and increase that. So now I have my my harbor here and my buildings, and that's LiDAR for you. Marinas, I guess, and the convention center right there. But I'm going to bring in my GeoSlam. The San Diego Convention Center has a GeoSlam from the inside. So I'm going to turn off my aerial one, and then I'm going to just look at this is inside the building. So I'm going to go inside the building. Okay. I have not been there. I do not know what this looks like inside, but I can imagine that if I go on the side of the building, which is, these are walls, right? Partitions, right? And there's more walls here, and I can find my my escalator or elevator that possibly is, and this is the outside wall, and that's a road. Anyway, this is what I wanted to show you. Let's look at the last few slides. Further resources to explore. You have Kentucky, the 3D depth program from USGS. You have the Kentucky from above. So we can explore this. You can just go online and look at it. You can download data directly. There's a map for downloading tiles of LiDAR. Kentucky from above, very powerful program. Very proud of it. You can download point cloud data directly. Commercial of the shelf, I've used the ArcGIS Pro software, but LP360, for example, and others. I mean, every single GIS program has capabilities now, modules for LiDAR, okay? The open source doesn't mean free, but QGIS is free. You can use it, and then Rapid Lasso, the last zip tools, Martin Eisenberg tools. There, I think that you can pay a small fee to get them configured. Have a license for them, but you can use them command line for free. So. This is what I have, and I appreciate your time. I think it ran a little longer than I thought it would, and have a great 2020 GS Day and beyond in your careers. And you know where to find us, so just give us a shout if you have any questions. And thank you so much for your time.